Hi, welcome to the ZP Developer Zone. So we do this webinar every every Sunday at 8 a.m. London time, and we do this sort of vlog and podcast, and we do a quick wrap up of the news from Zimmer Peacock for this week. So the first thing I'm going to do is jump into it and just talk about some of the technical work that we put out there this week. And one of the first things that we did was the detection of blood. So I think this is kind of an interesting question. Electrochemistry is actually particularly good at detecting blood, and we could do this, even when, so for example, if it's in a bandage or in a wound, somewhere where there's blood coming, but it's not necessarily observable, and it's not necessarily any light. It can be quite dark. So it has some, in terms of cost and applicability, it does have some nice advantages over maybe trying to do this optically. So we have put, as I say, put some notes out there this week, how we can sort of use our platform to detect blood. And then just to sort of, let's say, confirm and validate, we also went into the lab, pricked our fingers, put drops of blood onto our technology, did some experiments and got a very distinct signal, which we were expecting for blood. So blood does have a lot of molecules in it. Some of these are electrochemically active. We're clearly aware of these, and we were able to kind of go in the lab and just do a kind of quick confirmation, of that. And that's something that we did this week. Some other news from Zimmer Peacock for this week is we obviously have. I always talk about our developer zone, and I mentioned it at the beginning that. We do have a developer zone, and we use it as a forum in which questions can kind of come in, and we answer those questions, and we talk about technical questions generally. So this week we were talking about the use of PCB, printed circuit boards, as a vehicle upon which phosphate sensors could be built. We do put out materials and electrodes, and we give the webinar advice. Sometimes, though, the questions that people have are actually, they really need us to kind of work alongside them. So I think I did feel like it was one of those kind of ones where when they start on their own, they're going to run into questions, and they're going to need someone like Zimmer and Peacock to help them. And that's okay, but we did say that. So we talked about the phosphate sensing. Then we also had a very interesting question come in around which electrodes to use in sensing. And it's not that you can just use any electrode or any metal oxide. It's very conservative of me to say, platinum, gold, and carbon. But I explained that, it's these things are not just sort of randomly chosen. There's a... they're generally inert to these materials, and then when you try to look at things like copper and nickel, and I use those as examples, they generally tend to kind of corrode and oxidize, and so that's why people don't often use them in a sensing application. So it's not just that we're all super conservative and we use carbon, gold, and platinum just because we always have. We do consider other metals, and I did explain that those three materials are fairly inert, and actually you try to use other conductive materials, as I say, copper and nickel, then their intrinsic electrochemical activity can end up hiding your signal. So we did deal with that in quite a lot of detail, and I hope that was useful to the inquirer. Now, some other news from Zimmer and Peacock, or some technical information that we've put out there this week. It's unusual, but this so far we've talked about electrochemistry, the detection of blood. Something that makes us a little unusual is that we also have quite a strong IT backbone, and I know that many engineers in the world do. But with us, it's kind of unusual that we're doing electrochemical biosensing, and at the same time, we're working on Java and SQL databases. So I just wanted to highlight that this week, that when we get into programs with clients, we definitely work on the idea of building databases, sort of knowing where data is, knowing where part numbers are, we really take care of this sort of type of material. So, when you're doing a development of a medical diagnostic or any product of any type, you often have to know, obviously, the materials that go into that product. And so we're very good at constructing databases of things like part numbers and making all that, let's say, searchable. So that was something that we also highlighted this week. Something else that we talked about this week as well was the rapid analysis of whiskey. So at Zimmer & Peacock, we have a technology that we call Sense It All. And it has a sensor that can go into that called the spectrum sensor. And so what that allows us to do is take unusual samples, so for example, whiskey, and actually analyze it and get electrochemical data from it, and actually get information about the analytes from whiskey as well. So we put out a little note around that, and we again, we went into the lab and we actually did some work. We got the whiskey, we analyzed it by putting it onto the spectrum sensor, and so we sort of explained that. And what's really nice about our Sense It All platform is this kind of stuff can happen really rapidly with us. So we did discuss that this week as well. Something else that we did discuss this week as well, this is something that's been sort of brewing and going on for a little while at our facility, but it's also the detection of cough drops. So we did discuss that, and we also discussed something else this week as well, as the detection of heavy metals. So we did talk about platinum group metals and heavy metals generally so we can basically use electrochemistry, because electrochemistry is a very powerful technique for actually analyzing, for things like copper and zinc and nickel, and actually looking for those in water samples as well. And again, that is like the cough drop and like the whiskey comments earlier on, it is doing it in complicated samples, doing it very quickly, and doing it on our Sense It All platform. So something, just last thing this week is we're also, we get asked this a lot, and it's nice to have a sort of be able to say this in public, that we do a lot of sort of immunotype assays, and it's not always using antibodies. This time we've been using aptamers. Aptamers are, at least once the design is done, aptamers are fairly easy to synthesize. They can be robust, as long as when I say robust, they can be specific as long as they're designed properly. So the ask with aptamers is really in the design, but once you've got that design, they're quite good. And people like to use things like self-assembled monolayers to make them onto gold electrodes, which is something that we also like to do as well. So we did put some just a little note and a few diagrams up this week about the modification of gold electrodes for the detection of procalcitonin, as I say, using aptamers on gold electrodes. So if I was to summarize this week, we have talked about the detection of procalcitonin. We have talked about our Sense It All platform, and I've mentioned that the Sense It All platform, we've been using it for blood analysis, whiskey analysis, cough drop analysis, heavy metal and precious and platinum group metal detection. Also, we do our webinar for our DP Developer Zone members every Thursday at 8 a.m. So if you've got any technical questions, feel free to reach out to us there. Okay, well, thanks very much. And if you have